give 5 more minutes for other people to join. Thank you. Hi everyone. The most used emoji. Thank you, Oliver. Thank you. It's like it's only Oliver that is active on this call. Please, if you can hear me, kindly indicate. Thank you, Samuel. Thank you, Daniel. Thank you. Well, thank you. Thank you, everyone. Thank you, Taiwo. Thank you, Emmanuel. And thank you, Nena. You all are welcome to today's lightning section. It's a pleasure to have all of you on the call tonight. This section, like we already know, is organized by NAIJA-JUG user group, and I'm glad to have all of you here. It's really a pleasure. And for those joining us for the first time, NAIJA-JUG user group is a community-driven platform that is dedicated to bringing Java developers together and technology lovers in Nigeria and even beyond. Our mission is centered around learning, collaboration, and professional growth within the Java ecosystem. And we do this through our monthly sections. We usually have our monthly um, sections, technical workshops, and lightning talks like this every Tuesday, and also through our bootcamp programs, which is yearly. Yeah, so we aim to build like a strong space of Java developers in Nigeria, like just set a stage where we can connect, upskill, and grow together, where you can feel free to ask questions on the new trends and technologies in Java. And every day we have new trends and new things coming up. So, and we would love to have you. We love you to be part of our community. And I'll be dropping the links. One of my colleagues will be dropping the links to our social media platforms. Please feel free to join and ask questions if you have any confusion, contribution. All of them are widely accepted. Um, the speaker and the section will. Sorry, just a minute. Okay, I'm happy to let you know that NAIJA-JUG user group is proudly supported by JetBrains. You all know the JetBrains, and some of our sections we give out IntelliJ token for ultimate version. So please join us every Tuesday, and maybe one of these Tuesdays you'll be a winner of our IntelliJ token. So I'll be introducing our speaker for tonight, somebody that is very dear to me, and we have grown together in this Java ecosystem. She's somebody I know, and I really admire her journey in this career path. And she'll be taking us on introduction to microservices in Java. I hope that if you stay back, so you learn one or two or something that you've known before, but I'm sure if you have your question, feel free to ask. Okay, please, can you all hear me? Here, Deji said he can't hear me. Okay, okay. Aya, please, maybe it's your mic. Yeah, you all should join me to welcome our speaker for tonight, in the person of Nnenna. Please react with your favorite emoji while she takes this. Thank you, thank you. Thank you. Hi, Nena. Good evening. It's good to have you here.
Hi, good evening.
Hello.
Can you guys hear me? Am I audible?
Yes, you are audible. We can hear you and we can see you.
Okay. So my name is Ezidiegwu Nnenna, and for today's lightning session, I'm going to be explaining, just giving a broad overview of microservices and concepts around microservices. So I'm going to share my screen, and so you guys can see my slide. That's what I'll be using to explain. Hold on. Mm. Can you guys see my screen?
Yes, we can.
Okay. So I'm going to start by explaining what microservices are. Now, as you can see on the slide, it's a team of apps, not just one giant application. Instead of one application handling everything, we split functionality into smaller independent services that work together towards a common goal. Now, I would use an e-commerce service as an explanation here. Now, an e-commerce service handles identity management, inventory management, that's products. It handles order management as well, payment as well. It handles a couple of things. Now, instead of having one big app that has to handle all of this, you could just split these functionalities between small services. That's why we have the word micro. Micro is for small, something like small, basically. So instead of having one application that does all of this, we'll just have split smaller applications that would handle a particular responsibility. For example, we could have like a user service that would handle identity management, all this whole creation of JWTs and all of that. Now, we could also have a payment service. We could also have an order service, a product service as well. So that's basically what this microservice is for, just splitting functionality so that one app doesn't have to handle all of that. Now, all these microservices, each of them would have their own database, their own configuration, and its own responsibility as well. You won't see the user service trying to manage orders or trying to manage the product inventory or whatever. It has its own responsibility and it sticks to that. Now, I'm going to talk about a couple of concepts that we would see in microservice. I'm going to move to the API gateway. Now, API gateway, this is the main entrance. Every client request enters here first. The gateway authenticates the JWT token and routes the request to the correct downstream service without requiring the user to log in again for each one. Now, the way I would explain this is that a request is coming in from the client side. Now, this request, obviously, the user has, I told you in the user service, we have this where the JWT generation happens and all of that. So, and we know that a JWT has about three parts, the header, the payload, and the signature. So when this request comes, the API gateway, it validates this JWT and then it routes it to the correct service. So the user doesn't have to, if I'm moving from a user service to a product service, I don't have to log in again for me to have access to the product service. I've done that once, I don't have to do that again. So that JWT, once the API gateway sees, oh, this request is coming with the JWT, that's a token, it validates it and then it routes it to the service. That's it for API gateway. If I'm to give an abstract example, I would use, for example, let's say a shopping mall. Let's say you enter a shopping mall and you would like to buy donuts and you like to buy pizza or something. And donuts is being sold on the first floor, pizza is being sold on the fifth floor. As a customer, you wouldn't want to buy one on the first floor and then go to the fifth floor to buy another thing. If there was like a smaller session on the ground floor where you could tell someone there, where you could, maybe there's an employee there that you would tell, oh, I want to buy bread and I want to buy pizza. And then that person is responsible for routing those your order to somebody on the first floor for your bread and somebody on the fifth floor for your pizza. That's basically what this API gateway is for. It's just for routing your request to the actual service. So we'll move to another concept, config server, one place, all settings. Now the config server holds the application properties for every service in one central place, database configs, ports, credentials. If a port needs to change, you change it once here. Each service also keeps its own local config as a fallback in case the config server is unreachable. Now what this is in every service, obviously, we have an application properties here. And that application properties is where we have our DB configuration. We have a couple of things, even the ports. We specify a couple of things in that application properties here. Now, we could just have it. This is just a centralized point where the application properties for every service that is in that microservice, that is in that microservice architecture, basically. Every microservice there, we'd specify, you would add their app properties there. And if you want to make any change, you already know that you have to just come to this config server and make that change there. So it's just a centralized point where you can easily just make changes instead of you having to just run around. This is just a central point. Now for fallback, because I mean, there could be a case where the config server is down. In the individual microservices, we would have the app properties there as well, just in case anything happens to the config server, just for a fallback. So another concept that I would talk about is Eureka server. Now this is a service registry. Eureka server, every microservice registers itself here on startup. The API gateway checks Eureka to know where to route requests. Now, what this is basically, I mentioned that in the API gateway, when a request comes from the client side, it validates the token and then it routes it to the right application or right service here. Now, how does this API gateway actually know where that service is? Now, that's where the Eureka server comes in. Now, all these microservices here, they register on the Eureka server. So this Eureka server is where API gateway knows, like it checks, oh, where is this application actually running? And then it routes it to that particular place because it's specified on the Eureka server. So that's what this Eureka server is, just registers all the services. Now, this, okay, I said heartbeat every 30 seconds. Now, summary of what this is actually, it's a self-healing system. For example, in this microservice architecture here, we have a user service. Now, this user service sends like a ping or it notifies the Eureka server every 30 seconds. Oh, I'm actually active, I'm active every 30 seconds. If the Eureka server doesn't hear from it for 90 seconds, it drops off that service and API gateway doesn't route any request to that service anymore. Now, at any point where this user service comes up again, it automatically gets registered again on the Eureka server. So that's why I said it's a self-healing system. Once the service comes back up, it registers itself automatically. So that's what it is. Now, another concept we're going to talk about is RabbitMQ. This is basically just for asynchronous messaging here. Now, services communicate without waiting on each other. The payment service publishes a message to a queue. The notification service picks it up on its own time. Neither service blocks the other. Now, when we hear asynchronous, we already know that this one service is not depending on the other service for a response before it can do what it has to do. So, what this RabbitMQ is for is, now there are some terms that are associated to RabbitMQ, like producer, exchange, binding, queue, and consumer. Now, producer, the simplest way I can explain this is basically just the service that is publishing the message. Now, the payment service now, okay, payment is successful here. It wants to notify the notification service that, oh, this customer's payment is successful. Do you understand? So what this thing does is we have an exchange. Exchange is basically what carries that message from this queue in producer to the queue in the consumer service. Now, this exchange, how does it know the particular queue is carrying it to? Now, there's this concept, binding. Binding is basically what tells exchange, oh, if this particular message now has this routing key, this is where it's going to. So these are just concepts that are like affiliated to RabbitMQ. Just so that RabbitMQ is just for two services to communicate with each other synchronously. That's what RabbitMQ is for. Now, another concept we'll talk about is Zipkin. Now, this is for distributed tracing. When a request is slow, how do you know which service is the problem? Zipkin measures how long each service takes to process a request and gives you a full timeline. Now, for example, a user places an order, makes payment and all of that. But, I mean, it was successful here, but this took a lot of time and it shouldn't take this much time. How do you know what service is actually slow? Now, this Zipkin now allows you to be able to know. For example, when you check on Zipkin here, you see on the user service, this took about 30 milliseconds. On the product service, it took about 30 milliseconds. On the payment service, it took about 12,000 milliseconds. On the other service, it took about 30 milliseconds. So you can see that the delay was coming from the payment service. And now you know where to start your debugging or at least you know where to look at, basically. Instead of you being confused or changing things, tweaking things on the user service, which is not a problem, or the product service, Zipkin helps you to know that, oh, okay, this was at this point, this is when this whole process became slow. So that's what Zipkin is for, distributed tracing, basically. Now, another concept I would like to talk about is Redis. Redis is for caching. Frequently read data is stored in memory, so database is not hit on every request. Most useful in services like products, where data is read far more often than it changes. Now, obviously, if we come to a product page in an e-commerce website, it has, let's say it has categories, and then I'm going to the shoe category here. Now, I'm not the only user who goes to that shoe category. If it's like a really busy web application here, we are thousands or millions that are trying to go to that same shoe category. Now imagine on each user's request, you have to go hit the DB, hit the DB, hit the DB, hit the DB. It's obviously not going to work and all of that. At some point, there's going to be a problem. So what Redis does is, we see that, okay, this is a category that users visit from time to time. We just have a cached, we just cache it, and then we have that data stored. So we don't have to go to the DB every time. Now in Java, when you're building this application, we have a couple of annotations here. I just put a few of them, but there are more than this. And the first one is at cacheable. Cache the result of this method on the first call. At cache put, update the cache when new data is written. So let's say, for example, we have, normally for the shoe category here, we had about 100 shoes displayed there, but we've updated it. There's a new shoe there, so it's 101 now. What do we do there? We update the cache when new data is written. So we don't keep showing the user the stale cache, which had about 100 shoes. We'll show you the updated one that has about 101 now. So for this cache evit, clear the cache when user is deleted or stale. This is explanatory. So when data is deleted or stale. So if the data there is no longer being used, we've modified what we have on the product database. It just clears it off and it's been deleted. So moving on to load balancer. Now, okay, too much traffic spread out. When a single instance of a service is overwhelmed by traffic, you spin up another instance of the same service. Requests are then distributed across both. Eureka automatically reflects how many instances are running. So exactly, on that Eureka server registry here, there's a column where it specifies how many instances this particular service has here. So this load balancer, let's say, for example, we're about 100 users trying to make payment at the same time. Obviously, the payment service is there's going to be too much traffic on it here. So what this does is just create another instance of this service. Now, at least we get to like balance out the traffic here. So that's basically it, just for spreading out the requests that are coming into that particular service. That's what the load balancer is for. And for my diagram here, you can see the API gateway now routes the request to the first instance and the second instance. And the Eureka server actually shows you all the active instances that you have for a particular service. And we've come to the summary of my overview. So for the full picture, we talked about API gateway. That was where I gave the example, the abstract example of, when you go to a mall and you want to get something on different floors. So it's a single entry point, it routes requests, and it validates tokens. For a config server, it's a central store for all service properties. For the Eureka server, it's a service registry, self-healing, heartbeat-based. I explain what self-healing is. When the service is down for more than 90 seconds, it removes it from its registry. And when it comes back up, the service pings it again and it's back on the list. For RabbitMQ, asynchronous messaging, some keywords, producer, not really keyword, but like, this class is not for RabbitMQ, but there are some things that are stated RabbitMQ: producer, exchange, binding, queue, consumer. I briefly explained it when I was explaining what RabbitMQ is about. Then Zipkin, I explained Zipkin, distributed tracing, find which service is slow, so you don't have to go round and round and round tracking where your problem is coming from. This tells you, it was at this point that this request was slow. So you know the service that you're going to tackle. And then for Redis, in-memory cache, fewer database hits. You obviously don't hit your database every single time a user makes a request. You hit it. Nope. You just cache it. I mentioned that it's normally used in the product service. That's not only where it's used, but that's like the most common example. There is no way that you are updating your product let me say every day, every day, every day, every day. So like data that is frequently being read more than it is being modified, you can easily just cache those ones so that anytime a user requests for it, you can just bring it up and display without having to hit your database. And then load balancer, spread traffic across multiple instances. So too much traffic on payment service creates two instances, so at least it's spread out. And the API gateway routes it to both instances. So I think that's basically it. I'm going to stop sharing my screen now. Okay.
Wow. Thank you so much, Nnenna. That was fast, straight to the point, and it just hits the hammer on the nail. I mean, the nail on the head. Sorry. Please, if you have any question, please do it to raise up your hand or drop the question on the chat and ask your question. Thank you so much, Nnenna, for that amazing section. Let me just iterate on what I learned on this section about using Redis for frequently accessed data. You know that it is easy for you to catch your data. Oh, this data is frequently accessed. Let me just catch it. But most of us get carried away and we forget to invalidate those caches when the data have been updated. So I hope that if you didn't learn anything today, you learned that when you catch your data, always, always have a way of invalidating them. So that way you are not returning a stale data to your users or your customers. I think there's a question on the chat. Let me take that. Is load balancer implemented on the application layer or the infrastructure layer? This question is from Dominic. Yeah, so he's asking if a load balancer is implemented on the application layer or if it is implemented on the infrastructure layer.
It can actually be implemented on both layers, actually. Normally, it's typically done in the infrastructure layer, but in microservices, you can also have them in your application layer in Java as well. So mostly is in infrastructure, but you can also have it on your application as well.
Thank you. Dominic, I hope that is clear. Hi, Dominic.
Yeah, thank you. I really appreciate it.
All right. Please drop your questions, please. If you have any contribution, while we are waiting for questions and contributions, please do well to follow us on our social media pages. The recording of this section will also be uploaded to our YouTube channel. So please subscribe to our YouTube channels. That way you always get and turn on your notification button so you get a notification of our sections whenever we post. Please drop your questions. So, okay, there's a question from Taiwo Ayomide. Taiwo is asking, for services with multiple profiles, in a scenario where the config gateway fails, how do we configure the fallback profile to use? For services with multiple profiles, in a scenario where the config gateway fails, how do we configure the fallback profiles to use? So that question is from Taiwo.
Well, if I understand the question properly, yeah, I'm going to reiterate again when I said that if the config server ever fails, that the services themselves already have their own application properties, and that is already the fallback. So as for the fallback profile, whatever profile you set in your Spring Profiles active that exists locally is obviously what's going to be used.
Okay, thank you very much. Then, Taiwo, I hope that answers your question. Hi, Taiwo. All right, thank you. Amazing. Please feel free to drop your question and contribution. If you've worked with microservices before, is there maybe an approach, a cheat or a hack that you can share with us, something you feel we should know, or something you do that you would want others to adopt or you think works perfect for different scenarios? Please feel free to share with us. No question at all. No question is useless, so please feel free to ask your questions. Okay, thank you, Benga. You can go. You can.
Yeah, good evening, everyone. I celebrate the coordinator and the instructor for tonight. So I actually have a question, right? So about microservices, at what point in your experience can you like define that the boundary for each services? Like at what point of scaling or at what point of your growth do you say this particular module or whatever you're going to call it, module or a feature deserve a dedicated uh, service? So at what point do you define that boundary to scale out? And then during scaling out, is it a basic standard in your experience? Is it a basic standard that each of those services must have their own instance of a different database, right? They are not sharing database. So I want to understand the boundary. How do you define the boundary? At what points do you start segregating those service to scale out? Thank you.
Okay, just so I understand your question, even though I won't be the one to answer it, just to be clear, to be sure we're on the same page. You are asking that at what point in microservices do you decide which service boundaries for scaling? Like which service should have its own scaling boundary, right? Is that your question?
Yes, something like, say for example, in a payment system, you have like the wallet service, you have different category of features like modules, right? So when do you decide that each of those modules require their own dedicated service, or how do you define that, oh, this one can still stay with this particular service? Like, how do you define the boundaries before you start dedicating a separate service to a particular feature in that regard? Do you understand?
Okay, are you saying, for instance, what instance do I use? Let's say let me just use the thing that comes to mind. Let's say in my user service handles onboarding as well as authentication of users, like the login and logout stuff. So you're asking at what point do I separate onboarding from login, right? Sorry, I just want
Wh-
everybody on the call to understand your question. and me as well.
Well, something like that. What I mean is, you have different modules in your application. Some undo, let's say some undo booking, another one handles orders, another undo payment, something like that. So how do you define that this particular feature requires a dedicated service? Like, when do you start defining that boundary to extract a particular layer from a particular service? Let's say it's already existing on a particular, the whole thing is monolithic, right? Originally, at what point of scale do you decide to branch out different services?
I think you just made the question very clear now. So, okay, I think I understand you. In a monolithic application, at what point do you decide to separate them to go their Okay, your question is very clear now. Nnenna, over to you. You can also ask him follow-up questions if you didn't understand him. Okay, for me, um, if I'm running okay, I have like an application that I'm working on currently, and we are adopting the monolithic architecture, and seriously, we are looking at pulling out a particular service separately, and that is our payment and statement service, for instance, because of performance. So when performance becomes an issue, you would want to okay, to like okay, what's the word? Pull out that module from your monolith application and then run it as a separate service. So if performance is an issue, let's say for instance, if since our payment now is consuming, let's say 70% of the CPU, that's my nudge to know that it is time for me to have you as a separate application. You know that it's not all the time that our users are actually signing up, or it's not all the time that they are actually requesting for proof of funds or something like that, because it's part of what we do in the application. However, they are always moving money. If they are not doing the data part, they are doing transfers and all of that. So it's supposed to be just a mini application. However, the payment part is now carrying almost 70 to 80% of the CPU. So that was, and it's kind of affecting the overall performance of the application. That was our nudge to say, okay, this is time for us to move this. And also, another nudge for you to like pull out a module from your monolithic application, a separate microservice is deploying
Hello,
your.
Rosemary.
Yeah, can you hear me?
So you're off and on, yeah. So I don't know what's wrong with the speaker. So I don't know. On my end, you'll be high and you'll be low at the same time.
Oh, okay. Let me just remove this headset and bring the mic to
Oh,
closer to my mouth. So I was saying that your signal to separate your a module from your monolith application. Let's say you have user service module, payment module, statement module, what other module do you have? Notification module, security, and all like that, like that. So I was given an instance of an application I was working on that is a monolith application. And what gave us the signal that it was time for us to start exploring microservices, especially for a particular module, which was payment, was performance. So when you notice that one module, which was the payment, was taking almost more than 70% of the CPU, you know that is going to affect the response time and the request as well. So users will now be complaining your app is slow, your app is slow. That is your signal for you to explore microservice, especially for those modules that you know that they are frequently being accessed. For instance, user service module might not always be so busy because it's not all the time users are signing up. But for your core service, which in our own case was payment, users are always making payments, buying data, buying airtime, paying bills, requesting for proof of funds and all of those stuff. So that was our nudge to move payment service away. Another signal is also deployment. You find out that, okay, let's say you made a change on your payment module. At the point of deploying it, every other services within your application will also be down. Users won't be able to log in until your payment is completed. So, and we wouldn't want to do that since we know that our application is not only dependent on payments or POF or notification and all of those. So imagine if imagine if it is a, sorry, what's the word? If it's a microservice, once you are deploying the payment service, users will still be able to log in. They won't notice that something is going on there. So deployment is also a signal for you to pull out a module from your monolith application and move to microservice so that all your small fixes, that bug fixes that you are doing will not affect the traffic. And you can even also deploy when customers or users are actively using the application. And cost also. Cost is also one of the things that will tell you, okay, oh, it is time. And you also have to consider the risk that is involved. You understand? Because for instance, if for instance let's say one thing in your monolith application is down and it affects the entire application, but you know that notification service can be down, but meanwhile our application will still be up. That is just the joy and the advantage of having microservice. Sorry, I don't know if I've been saying a lot of things, but just shared from my little knowledge.
Yeah, I understand your answer. Thank you very much.
All right, thank you, Benga. Does any other person have a question or experience with what the question Benga asks? Remember, our goal is for us to network, learn new things, and also contribute to the growth of other people within the Java ecosystem. So please feel free to ask your questions. And also follow our social media channel. We'll be dropping it again. Okay, in the absence of every other question, I want to thank our speaker for today, Nnenna. Thank you so much for this powerful section today. I personally, and we want to thank you on behalf of the entire NAIJA Java user groups. We say thank you and we hope to have you some other time. Thank you. Please, we all should drop an appreciation emoji for our speaker for tonight. I think Emmanuel just dropped something on the chat. He's saying, I think, Dominic, this one is for you, though. He said, you can look at it this way. There's client-side load balancing, which is the Eureka, and also which happens in the application layer and server-side load balancing, like Kubernetes, which handles the routing and service discovery outside your application. Yeah, so Emmanuel and Dominic, please, I hope you guys are already on our community channel, WhatsApp group, so that you can link up and get clearer and better explanation. I want to thank everyone for joining our lightning section for today. Thank you. You all are the real MVPs, and we hope to see you again next Tuesday. Please, if you want to share from the abundance of your knowledge, you want to share your experience with us, you want to take a lightning section, please feel free to reach out to us or any of the Java user admins in the group, and we'll be happy and excited to have you. Thank you so much. Shout out to all the admins, Gloria, Ebude, Nnenna. Thank you all for joining. Thank you. We sincerely appreciate. And I want to give another shout out to our our partners and sponsors, JetBrains. Thank you all for joining, and you all have a restful night. Thank you.